Hello Algebra 2 students, this is lesson 21. Our objective for today is how do you work with scientific notation and how do you solve two statements of equality equations. So let's just do a quick reminder of what scientific notation is. Remember, scientific notation is whenever it's in this form right here, a number times 10 to the n, where this number, I'm calling it a, is less than 10 and greater than or equal to 1. So kind of thinking we want it as just like 1. We're not going into the tens place, we're keeping that number in the ones place and decimals. And that exponent is an integer. That's what this means. N is a member of the integers. So which of these is in scientific notation? Well, notice this number right here, in this case a, is actually 33. That is not a less than 10, right? So this one is not in scientific notation. Looking at this next one, again, this number right here is 0.03. That's not bigger than 1. That's like 3 cents and some change. So it's not bigger than 1, so that one's not in scientific notation. And then lastly, this one is 3 point something. 3 is bigger than 1 and less than 10. So that means this one is in scientific notation. Just a quick note over here on the right, if you're trying to change something into scientific notation, if you move left, meaning if you need to move this exponent to the left, then you're going to add to the exponent, right? Because if I moved it over here, like right now it's saying 1, 2, 3, so decimal place should be at 4. If I'm going to move it 1 to the left, I'm going to have to move one more spot to the right in order to get back to the same place. So you add to the exponent. If you're moving it right, like right now it's supposed to be here, so if I'm moving it right, I don't have to move it as far because I've already moved it some, so I would subtract from the exponent. And then I guess I also should make the note that, remember, if this exponent up here is large, meaning if it's a positive number, then this number is going to come out to be very big, and if it's negative, this number is going to be very, very small. Again, this should be mostly review for you. I think we've done scientific notation before, but that's just a quick review of that. To write these in scientific notation, I need to move this 1 to the left, right? I'm moving left, which means I'm going to add to the exponent, so this would be 3.3524 times 10 to the 4th. Since I moved it left 1, I'm going to add 1 to the exponent. This one here, I'm going to need to move it 1, 2 to the right. So since I'm moving it right, I'm going to subtract 2 from the exponent because I'm moving it 2 places. So it would be 3.3524 times 10 to the 4th. So if you notice here, actually all three of these numbers are representing the exact same number. Alright, so now let's work with the sum. Now we're asked to simplify this expression. So we're going to start off by writing each of these in scientific notation. So this one I need to move 1, 2, 3, 4 places to the right, which means I'm going to subtract 4. This decimal is here, so I'm going to go 1, 2, 3 places to the left, so it's going to be times 10 to the 3rd. I'm going to add 3. Moving this 1, 2, 3 places to the right, so I'm going to subtract 3. Here moving it 1, 2, 3 places to the left, so I'm going to add 3. So writing this in scientific notation then, it's going to be 3 times 10 to the negative 10 times 4 times 10 cubed, all divided by 6 times 10 to the 12th times 2 times 10 to the 7th. Now let's do a little bit of rearranging here. Remember, when you're multiplying numbers, the order that you multiply them in doesn't matter. So I'm just going to rearrange both the numerator and the denominator. So I'm going to say 3 times 4 times 10 to the negative 10 times 10 cubed. And notice what I did there is, here's the 3, there's the 4, 10 to the 10, negative 10 to the 3rd. So I have all these pieces I've just rearranged. I've put all the tens with exponents together and all the other numbers together over here. Do the same thing with the denominator now. 6 times 2 times 10 to the 12th times 10 to the 7th. Now let's simplify down. 3 times 4 is 12. 6 times 2 is 12. When the bases are the same, you add exponents, so this is going to be times 10, negative 10 plus 3 is going to be negative 7. Adding exponents down here is going to be times 10, 12 plus 7, it's going to be 7, 8, 19. Notice my 12s. 12 divided by 12 is just simply 1. So then I'm going to have 10 to the negative 7 over 10 to the 19th. This is negative exponents. I'm going to pull it down. So this is going to be 1 over 10 to the 19th times 10 to the 7th. 1 over 10 to the 26th, because I'm adding those exponents. And then I'm assuming, since we started off with scientific notation, we're going to write that in scientific notation at the end. So I'm going to pull this back up top. 1 times 10 to the negative 26. Alright, now these are now solving two statements of equality. If you look up here, I've kind of gone through and looked at keywords. A ratio means division. Is implies equals. Sum is to add, and is to equal. And we're looking for two numbers. So what they've done is they've made two statements. The ratio of two numbers is 4 to 5, and their sum is 108. So let's see if we can take this and write some equations. So the ratio of two numbers, so I'm just going to call my two numbers x and y. So x over y is 4 to 5. 4 to 5. There's one equation. And my next equation says their sum, still referring to those same two numbers. So their sum is 108. So x plus y is equal to 108. So now all we need to do is solve this, and you can use substitution, elimination, whatever you want to do. I think I'm going to use substitution so I can get this out of the y out of the denominator here. So I'm going to use this first one in step 1. X over y is equal to 4 over 5. Multiply both sides by y. So that way this becomes 1. So I'll have x is equal to 4y over 5. Step 2, I'll use this other equation. X plus y is equal to 108. So this is going to be 4 over 5y plus y is equal to 108. This is like 5 over 5y, so this is going to give me 9 over 5y is equal to 108. Let's multiply both sides by 5. So now we have 9y is equal to 540. I did that on the calculator. And then we want to divide by 9 to get that y by itself. And we get y is equal to 60. So that's one of my numbers. Then step 3, x is equal to 4 times y, which happens to be 60, divided by 5, 240 over 5, x is equal to 48. Alright, so that's this was part A. Now let's do part B, which is kind of the same idea, just the same thing again. So part B says the sum of two numbers is 36. So I'm going to call them A and B just for fun. A plus B is equal to 36. And it says, and their difference is 50. So A minus B is 50. Well, I can choose either substitution or elimination, whichever I choose, but this looks to me like this would be a perfect opportunity to use elimination, because I'm looking at this has an A and an A, but even better, this is a positive B and this is a negative B. So if I were just to add these right now, my B's would be eliminated, and that just make my life a whole lot easier. So let's go ahead and do that. So I'm going to rewrite this equation under here. A minus B is equal to 50. Add those up. 86 is equal to 2A, because remember those B's went to 0, 0B is 0. To solve that, I want to divide by 2. That means A is going to equal half of 80 is 40, half of 6 is 3. So A is equal to 43. Then I just need to plug that in anywhere I want. I'm going to plug it in the first equation here. I'm going to say 43 plus B is equal to 36. So subtract 43. B is equal to -7. So those are my two numbers, -7 and 43. Again, if you added them, you get 36. If you subtracted them, alright. Good luck, guys. Your homework's written up on the board in my classroom. Good job.